As I'm sure introduced, my name is Shakti, full name Shakti Shalini Nagaraj, and I am with Arden as a lecturer currently. Previously, I used to work for Coventry University, and before that, I used to be a software developer turned program lead for a major software company. So I have worked with a lot of banks, mainly on the software side of development and project implementation and digital transformation for those banks. So after being in industry and then now into teaching, where I also do a lot of research, specifically focusing on digital transformation and sustainability and AI applications. So this particular topic has come to me quite often in my mind as it needs a lot of exploration and practical implementation in academia specifically, because I see that there is a large gap in terms of what industry expects and what we are offering students. So that's the starting point for my research. And it was purely a secondary desk-based research that I've done, with which I have come up with a few frameworks, which I thought will be interesting to present to this group of academics here. So before we start, I just want to set your mindset for this presentation, just to give a view of what kind of a discussion this might be. So I'm just asking this question of why do we say industry skill and not industry knowledge? If you have some thoughts, you can post your answers in the chat box. I want to see as well, but Anshul, is it possible for me to escape the full screen view and also see the answers?
Oh, you can,
Like, I'm just
absolutely.
going to try that. It might be just, yeah. So if you all want, you can tell me like why you think, as I said, it's called industry skill in general, and we don't call it industry knowledge. Any thoughts?
Oof.
So if you're thinking about it, I just have one more question again for you. And why, I mean, we know how the static assessment system works in HE, right? And also we know the dynamic assessments where we can have multiple submissions from students. So my question is, keeping that as in mind, do you think people in industry write reports and presentations on a daily basis? So you can think about these questions, or you think their work will be using various tools given to them where they keep accessing these tools and perform their jobs on a daily basis. And of course, they will also be sometimes producing reports and presenting their findings. That will also be part of it. But then what about the majority of the work that they will be doing in industry on a daily basis? That's a question to think about again. So do you think language and intellectual skills, which usually now we want to address in higher education for widening participation students to create more inclusivity, etc. So now my question is, do you think language and intellectual skills will be barriers for developing skills in using certain tools, like for example, Firefly, an Excel spreadsheet, or a PHQ tool in psychology? So this is another question to think about. So, and the last question is again, these skills, which are industry tools as such. So do you think they can be improvised with practice? And also, do you think language and other cognitive skills can be barriers in development of skills for using these industry tools? So that brings us to the discussion itself now. So the real barrier is not language or intelligence. That's per my research and experience. And it's only the lack of exposure, confidence, and supportive learning design, which gives these tools to the students so that they get hands-on experience. So the methods which I will propose will be totally very, I mean, they will be in mind in including the students with widening participation needs as well. So first, let's begin by looking at the gaps themselves. So what I call these are the current industry tools are those tools which are right now predominantly used across industry, be it psychology or business management or healthcare. All industries, definitely they are all operating based on certain tools which are made available to the employees and probably by using a computerized system which they will be accessing. So there are current industry tools specific to any industry we pick. And then there are also the new technologies which are just coming up and we are still adapting to them, like AI, possibly, like we just had discussion before about how adopting AI is useful and learning prompting is useful. So likewise, there are more industry 4 technologies like robotics, digital twins, all of it. So there are new technologies which still industry is struggling to implement. And then there are these current tools which industry is using. So there is a lag even with industry adoption of new technologies. And nextly, universities come here, where we are trying to provide education and prepare graduates who are readily equipped for going to industry. So what industry expects from the graduates from university is that they are employed with all the skills they require to perform their duties in industry. So now the question is, are universities, first of all, providing the or exposing the students to the current technology tools? That's the first question. And the second one is, now, even if we are exposing to the current technology tools, also are we giving them the chance or ability to develop and adapt to new technologies, which might land when they finish their studies after 4 years or 3 years, right? So what we are teaching them or they learning today as part of their learning and assessment may not exist when they graduate, isn't it? So there are these tools which industry uses currently today. Are we first exposing our students to those tools? Are we giving them practice in them? Plus, also, are we giving the chance for them to develop their skills in order to adapt to new technologies which might land later? So these are the two gaps that the study focused. So what are the gaps? Understanding and fluency in using current tools, which are in industry, which are technological tools, of course, and then the ability to learn and adapt or make decisions of whether a particular new technology is useful to their industrial practice. So that's the second skill. So there are only 3 ways through which we can reach students, right? So I split the overall, as I mean, what we are just broadly discussing as industry skills. I'm putting them in as 3 skills, which employers expects, and then the 3 routes with which we can reach students from universities perspective. So the soft skills, very famous, the hard skills, and then I call specialized hard skills. So these are the 3 hard skills, I mean, 3 different skills per Harvard's Harvard Business Research. And these are the only 3 skills which we can only embed to students through 3 routes, which are seminars or tutorials that we have with them, the lectures itself, where we teach them, and then the assessments with which they learn what we are teaching. So these are the 3 routes only through which we can embed all these 3 skills into the students, right? And I call that the soft skills, which the students require. So that's being the foundation in any discipline. The soft skills are considered foundation as per this research from Harvard. And the core hard skills, which are specifically for a domain that they will be employed in, these are non-negotiables, they call. So if it's psychology, then the technical hard skills that come with the psychology, these are non-negotiables. Same with business management studies. And the third is the specialized hard skills, which could be advanced skills in the same industry-wide or domain. And these could be a differentiator for the student who gets these skills within them. So these are the 3 categories where soft skills will be the foundation skills. The core hard skills are non-negotiables, without which the industry jobs cannot be performed. And then specialized hard skills are advanced skills in their domain, and they can act as differentiators among the student cohorts. And the 3 routes: seminars, lectures, and assessments. Let me pause it. Oh, yeah. So now how do we embed these skills into the 3 ways that we know? So I come up with this balanced competency model, which is again based on researches from previous studies where, for example, this is a scenario where for a software development manager, the research suggests that industry expects 60 to 70% of soft skills from the candidates, and 20 to 30% of hard skills, which is general technical competence, is being expected from industry side on students or candidates. And the last skill, which is the specialized hard skills, they are considered or given a weightage of 10 to 20%. So what I suggest or have come up with is based on the level of study that we are teaching, plus the course specification, which will be our main skeleton or guidance to come up with the entire course design, right? So the course specification, and also considering the industry needs for that particular domain and possible job roles in future, we assign this percentage of whether it will be 60 to 70 soft skills or any other percentage number. So we fix the percentage of the three skills basically based on the three things which I've said, like the level of study, your course specification, and the industry needs. So you come up with a balanced competency model for the level of course you're teaching, and then you embed these three skills into the curriculum. So now, before we go further, there is a question for you now. What we generally think a curriculum will be? So what elements will contribute to a curriculum? So in general, we will speak about the research, the materials, the lectures themselves, the seminars or labs that we are doing for them, the workshops, or what kind of assessments we are keeping for this module, or what all modules they are learning. So all of this will contribute to the curriculum, of course, but also all the elements involved in providing the curriculum to the students, which will include the mindset and ability of us, the teachers, the instructors, the curriculum designers, and also the course leaders, or even the management who are approving budgets and etc. So the mindset and ability of all of us together also as part of the curriculum. The technological tools which we are offering to the students and teachers, which enable their learning or assessment path. So all of this still is part of the curriculum. So keeping this in mind, now going to how we embed core hard skills. So the core hard skills, which I said are the non-negotiables, and for that particular course of software project manager, a 20 to 30% of core non-negotiable core hard skills. So I've just come up with a module design likewise, where I have said every time I'm talking about a module, I'm also keeping a column which states clearly the digital tools that could be embedded, which are directly coming from industry awareness. So for every module or every particular course we teach, as we know the domain and as we know the possible employment roles for the current students, then we come up with the digital tools by having close industry partnerships, which is again a mandate for any university. So we have these tools embedded into the modules themselves, and the assessment methods or the workshops, all of them focus using these tools as part of the learning. So if you can see here, there is an example. If we take the business analytics fundamentals, which is the fourth in my table here. So it's just the Excel basics. So if it's say foundation level students, we could ask them to use a workbook so we can demonstrate and help them access Excel, and then create a formula spreadsheet where they will embed their own formulas and create, or we can ask them to create graphs using data provided from our end. So using Excel and analyzing them basically, or helping them basically to use an Excel for analysis as an application. So this is just one example that I have, I'm trying to bring in this presentation, but we can do a lot more things with the tools available for industry, and also if we can employ that for our education. So this I call as a core competency model, where the core hard skills are totally included or embedded within the curriculum. So we ensure that the technical tools are embedded within the assessments, embedded within the lectures and workshops. So tutorials should provide practice using these tools, and the assessment should also evaluate how students are applying these tools in real practice. And of course, the theory that we teach is the backend for all of this. So they learn the theory and then they apply it directly on the tools. So that's the main idea. So this way, the assessments definitely turn very authentic. And that's the bigger trouble we are all dealing with in our current practice, where AI is dominating assessments, and we do not know how to validate the authenticity of the assessments, fairness of the assessments. So this way, the students will have real experience on using the tools, and no AI can help them to actually do the task, whereas they will be doing the task. So the tasks are very much industry aligned. So the picture here shows another example where it's a small workshop where I have given a manual calendar, and the students were asked to convert this to a Gantt chart using Excel. So it's a very simple exercise, but it's powerful for the daily use in industry as a beginner. So coming to the soft skills now, which is definitely the larger percentage in most domains or most sectors, the soft skills are required in this kind of a percentage, which is 60 to 70%. So the suggestion is to embed them as part of their teaching in a parallel competency framework. So alongside the theory and the core hard skills, the soft skills are always coming in parallel. So which means through active learning strategies, which I think most of us already practice this. So within our lectures, seminars, and assessments, we try to embed the experience to gain soft skills. Like for example, in data analytics module, where Power BI is an industry's tool. So the industry tool is always there, which is the core competency framework, because it has to be embedded within the module and the course. So Power BI is there. Now students are analyzing the given Power BI dashboard. So we are not asking them to come up with a dashboard or make decisions, which could be really advanced. But this particular exercise or a workshop is only asking them to validate a Power BI dashboard and deliver a 5-minute insights pitch into what the dashboard suggests, and their words or the particular wordings which they will choose will be or should be relevant to non-technical audience, which means the managers or senior managers. So this could be a small workshop for them to use Power BI while also gaining their soft skills. And another example in project management, where students role play a monthly project meeting with 2 different departments or teams. And for business finance, they create an Excel. So obviously in finance, nobody is doing the calculations in industry every day. We teach the foundations, but then we assess them or also give them an access to using Excel and formulas in Excel, where they can simply use Excel spreadsheet to calculate the financial ratios. So we ask them to come up with a quarterly budget in business finance by giving the numbers to them. So these are some examples of how we could develop the soft skills and core hard skills. Now, before we progress to the specialized hard skills, I want to pause for a moment and then think about student progression. Because we all know that we have all kinds of students with varied capabilities, and we call that widening participation these days. So it would be too much for most undergraduates if we attempt to deliver the theory, which is what we always deliver, plus also the hard skills, which are the technical skills and usage of tools, and also the soft skills. So all of this going in full depth inside the core curriculum would be too much for sometimes for some students. So we always talk about needing to scaffold their learning and not overloading with too much of information or too much of tasks in their learning path, right? So the goal is for us to build competence gradually and not to turn every module into a professional certification by itself. So this also is something very much important for designers in education to be aware of. And yeah, as we keep designing, I just want to pause here to ensure that we have this mindset, and then we go into something called a sustainable curriculum. So this way we balance the 3 layers that I was talking about. So the foundation hard skills and the soft skills, they are integrated into the learning, where I said they will be part of the core and parallel competency framework. Whereas when it comes to the differentiator, which is the specialized hard skill, the idea is to provide that as a light touch exposure so that the students understand what they are and why they matter, and they can stretch if they really want to learn these specialized hard skills. So they can be offered as optional modules or specialized pathways in final year, which is mostly happening in masters or an MBA, but not in general for all kinds of studies. So providing optional modules or specialized pathways in every level is good. When I say level, I meant level 6, which is for the bachelor's themselves when they complete. So on their final year, they could be provided an opportunity to pick up these specialized hard skills as an embedded light touch exposure. So this is where the deeper specialized hard skills are developed. So it can be an option for those students only who want to extend their experience to more advanced tools and frameworks, so that we don't have to overwhelm the entire cohort with this. So an example is a digital transformation project. For example, in final year, students can choose between a standard track, which is of more conceptual and managerial in terms of its work, in contrast to another path where it will be advanced technical track, where students will provide hands-on or they will provide or submit their work with hands-on or specialist tools being used in their assignment, like Power Automate or Azure Logic apps. So this is for the last skill, the differentiators, which is the specialized hard skills. And this is only 10 to 20% in expectation from the industry. So we do this in terms of an approach, which I call a tiered approach. So as throughout this presentation, you might have noticed that I was saying if it's level 4 we do, or we introduce the skills, or we provide the exposure to the skills, and we assess them only for the foundational or the basic level of operating those tools. And then we keep moving towards the mastery in using such tools. So from 4, 5, 6, I've just given 4 where we will be focusing on assessing them only for awareness on tools. And 5, we would be focusing on their competence in using these tools. And in level 6, we might want to check their mastery in using tools. So this could be a tired way of, again, assessing them or teaching them, and how we design the module itself, module or the curriculum for them. So this is just a full picture of how a curriculum might look. So it has a lot of information, but just to give a quick view. So I have given the level 4, 5, 6 over there. And the focus is foundation in level 4 and applied core hard skills in level 5, and the specialized hard skills are focused in level 6. And as I was saying before, awareness, competence, and mastery come in a tiered approach. And then the modules themselves. So I have just, this is my own working for a sample presentation to you all, but it's nothing where I have done this practically anywhere or tried this empirically. So this is just something I've come up with for us to understand what is the suggested framework here in terms of curriculum design. So those are some example workshops and assessments with the industry tools embedded as part of their learning. So the tiered approach is definitely going to provide students confidence, because it's not easy for anybody, even the educators ourselves, to have hands-on experience in all tools in industry, right? So everybody together, we build confidence from the beginner stage to becoming mastery in using a tool. So before tackling advanced material, we definitely want to do this in a scaffolding manner. So we begin with being beginners to being masters in using tools. So students build confidence gradually. That's our approach. And the curriculum will remain this way inclusive for all cohorts with widening participation also. And like I said in the very beginning, language or intellectual skills are not really barriers for learning the tools. Or so definitely using industry tools or becoming masters in them comes with practice rather than their their particular intellectuality or language barriers that they might have usually. So the curriculum remains inclusive for sure. And as I said, because of the lighter exposure, the stronger students who can stretch a bit, they definitely have the option to be the differentiators later from their cohorts and also in the employment journey further. So the program this way overall will remain academically rigorous in a good standard, and it doesn't overwhelm learners as well. So now coming lastly to the challenges, what we might face as educators, the challenges. So first one is curriculum overcrowding, because this seems very interesting and good. So it's a natural temptation for sometimes people who are really excited about this to include every relevant tool in industry in there. So we have to be cautious, and we need to understand that overloading modules leads to shallow learning, rushed assessments, and student burnout. So the challenge for educators or designers in education will be to prioritize what is essential, what is versus what might be just nice to have. That's the first challenge. And second is student motivation and perceived relevance of undergoing this. So if the students are not understanding the purpose of introduction of these tools and why we post them or make them use these tools, they would have very low motivation in coming up, because they generally come to a lecture thinking that we will be talking and they will just be listening. So some of them, they do not want to participate. So only when students know that these tools are there only to make their jobs easy now as well as in future work. So it's part of, again, the lecturers and module designers to provide them that kind of a relevance in using these tools and making them understand how easy it will be, I mean, their job as well as their study here when they do or use these tools for understanding the theory and making them happen. So skills translate into real roles. So that's what the students need to understand. So we have that challenge to make students perceive that. Third one is staff expertise and training. So as we all know, many of us academics, we are very strong in research, teaching, conceptual teaching, but we ourselves may not have hands-on experience with a lot of industry tools or the enterprise platforms, it says here. So we also have to contribute towards staff development. That way, the curriculum becomes very consistent. The students provide, I mean, the students are getting rich staff and rich tools. Yeah, so the staff also require expertise and training for using these tools, and also licensing, accessing, and infrastructure in incorporating these tools in our university systems will also be hard. That's just a temporary problem because a lot of tools, once we have started using, they are very easy. And most of the industry tools, they have student or learner versions now, which have most of these versions, which are easy for anybody to access by creating signups or logins. And we can provide these tools without a cost to the university for only the preliminary features, which are more or less enough for most of the studies we want our students to do. So yes, initially the infrastructure setup will be hard, but then if we make the effort, if we set up projects within our university groups where interested lecturers can come together, this can be made possible as well. So the assessment feasibility is one more thing. So we are all very much used to the traditional way of handling assessments where bulk submissions land in and then we do marking, then we do moderation. So we have that pattern. So it's also hard for us to now make assessments using these tools work. So that's something for, again, individually the model leaders and the designers in course to work to make this feasible and how it adapts to our current learning and assessment system so that it's not a radical change, but then we do by first embedding within our current system and then go from there. And the last one is the pace of innovation and industry lag, which I showed at the very beginning of my slides, where I said industry itself is having a lag in adopting newer technologies. So we can't beat that. So when we have decided that these four are the tools very much used by industry or predominantly available in market in industry, and we are teaching that. But then after 5 years, that tool is no more. So this can very well happen. So again, we have to be in very close contact and relationship with industry, or we have a lot of industry partners to whom we collaborate frequently, and we have this module refresh cycle, and we every time have industry partners while also we consider designing or redesigning our modules. So these are all the challenges in embedding this, but the benefits. So we are talking about multi-component assessments and we are evaluating practice as well as knowledge here. So it's going to overcome the problems of usage of AI and which is the most discussed topic, which we even just before we were discussing quite a lot about it. And also the second benefit is employers are definitely getting graduates with both breadth and optional depth. And this aligns perfectly with UK's quality code for higher education of the assessments being authentic and several more checks in terms of meeting the standards for UK and QAA. So it aligns perfectly with the B3 metrics as well, specifically for progression. So the summary for this session is there are two gaps to fill: the current industry technologies as well as the ability to adapt to new skills which come afterwards, after 5 years or 6 years and maybe tomorrow. And then three skills to look at, which are the soft skills, core hard skills, and specialized hard skills for any domain we pick. And then we create a balanced competency model of assigning percentage to these three skills specifically for your domain based on the level of study and the course and the industry standard. And then for these three skills, the core hard skills and foundational skills are embedded within the curriculum and they are part of teaching and practice and assessment. And then we talked about sustainable curriculum, where we do not want to overwhelm students with too much of skills and tools and practices. So we want to take this as a scaffolded approach. So the specialized hard skills are provided in the final year as an optional pathway, only for those students who want to really stretch. And also we can provide industry-aligned micro-credentials when they finish these specialized hard skills. So this way, following a tiered approach within the program has its benefits of providing or having inclusivity in terms of student cohorts. So questions now?